Hello, we have a fixed beam. I have already drawn the reaction forces on this, and I would also note that you should have your equivalent point load, which would be 25 newtons. I have my reaction AY, my reaction AX, which we know is going to be 0, and then I have my moment about point A, and I'm showing it in a positive moment there. So I'm going to solve for my reaction forces in order to draw my shear and moment diagrams in order to visualize and analyze the shear on the beam and the bending moment on the beam in order to select materials and figure out what I'm going to be doing later on to be able to withstand all the forces that are acting on this beam. So if I sum my moment about point A, please pause the video, solve for these, and then come back to it. I'm going to have 25 newtons times 7.5 meters. So that's going to be 5. This is 2.5 feet away, so 7.5 meters minus 5 newton meters minus 10 newtons times 15 meters plus the moment about A is all equal to 0. Moment about A is equal to 342.5 newton meters. If I sum my forces in the y, I get that AY minus 5 newton meters times 5 meters minus 10 newtons is equal to 0. So AY comes out to be 35 newtons. So those are the two reaction forces that I'm going to be needing. And then if you sum your forces in the x, you have nothing. So that's just going to be 0. So drawing my shear diagram, I've got AY is 35 newtons, so I come up to 35 newtons. At 35 newtons, I'm going to be going across, nothing happening on the beam. So I come straight across. So that's 35 newton meters. I'm sorry, just 35 newtons. Then I'm going to be dropping down because I have this distributed load. So I'm going to be dropping down to 10 newtons. 35 newtons minus 25 newtons is going to give me 10 newtons. I can't draw a straight line. One more try. That's better. Nothing happened on the beam, so I come across. Now nothing happening right here as far as shear goes, so I continue go across. And then I'm going to come down at 10 newtons. Since I'm at 10 newtons, I drop another 10 newtons because of this force at the end, and it closes. So I'm going to draw these little lines real quick. And I'm going to solve for my areas in the shapes. So 5 times 35 is 175 newton meters. Now this is two shapes. I've got a triangle and I've got a rectangle. So I have 10 newtons times 5 meters plus 25 newtons times 5 meters times 1/2. That's going to be 112.5 newton meters. In this area here I have 30 newton meters. That's going to be 3 times 10. And then here I've got 2 meters times 10 is going to be 20 newton meters. So now on my moment here, remember what I said in the previous video. If I have a positive moment, I'm going to be going down. If I have a negative moment, I would be going up. So I'm going to be dropping down to 342.5 newton meters. Then I'm going to be going up 175 newton meters to about this point. So if I continue this, draw this green line down, it's about right there. I would be able to go up to 167.5, 167.5. Then I'm going to get to about right here, and this is going to go like so. Remember Kahn's bug. Kahn's bug has its legs. Oh, it doesn't want me to draw that there. Hans bug. No, it's kind of an ugly bug, I apologize. So that's why I have this positive, because it's above the x-axis and it's coming, my shear is coming down, so that's going to be going up like that. Then here at 30 Newton meters, here I was at 55 Newton meters, so I'm going to shoot up to 25 Newton meters. That's just 55 minus 30, it's going to be 25 Newton meters. I go up here, and that's going to be 20 Newton meters. And then 20 Newton meters, I have 20 Newton meters here, so it's going to shoot up to 0. So again, my moment diagram does close. So my moment max was 342.5 Newton meters, and my shear max is equal to 35 newtons. And that's what I was solving for, is my max and my shear max and my moment, bending moment max. And I know that would be difficult if you tried to do this in intervals, little tiny intervals. You could come up with equations and plug and chug in to see what your moment max is. And we can do that here in a little bit to find possibly a bending moment at this point, the shear at this point. So we can come up with our equations, and I'll do that in a separate video. All right, thanks for listening.